The topic of this video is to use the law of sines to solve a triangle when two sides and an angle are given. This case is called SSA, or side-side angle. It is actually called an ambiguous case because there are three different possibilities that can occur. We will either get one type of triangle that will satisfy the information given. We may even get that there's no triangle that exists that satisfies the information that's given, or there are two possible triangles that will satisfy the information given. Your book actually goes through all the different cases where you can memorize how those values of A, B, or C, or the angles relate to each other to determine which case you're in, and I have never memorized those. You can figure that out as you go through the process of solving. So I would say just rely on the law of sines and the knowledge that you get as you go through the process to solve, and you're going to determine which of the cases you're in. So let's look at a case where we want to solve a triangle if we know that angle A is 62 degrees, lowercase a is 10 inches, and B is 12 inches. So I have the triangle represented here, so what we're looking at now is trying to find what values? Yeah, we need to find two angles. Right, there's 6 parts to a triangle, so you're going to know 3 of them, and you've got to find the remaining 3. So we need to find out what the value of angle B, angle C, and lowercase c are. So we would set up, we know information about angle A and lowercase a, so that definitely has to be in our ratio. And then we also know the value of B. So we would need to say sine A over A is equal to sine B over B. So we would get the sine of 62 degrees over 10 is equal to sine of B over its side opposite, which is 12. And now we multiply by 12 so that we get sine B on the side by itself. So we get 12 times sine of 62 degrees over 10 is equal to the sine of B. Well, whenever we use our calculator to find this value, we get 1.06. Now, typically, you would have sine B is equal to 1.06, and then you could use your inverse function, inverse sine, to solve for B. But what's wrong with this problem? Yeah, what has types of possibilities that you can get from sine B? Right, do you remember the range of sine is what? It is -1 to 1. So is there an angle whose sine is 1.06? No, this is impossible. So there is no triangle that has these conditions. Now I've actually constructed it to show you what would happen if you really tried to use a ruler, a protractor, and draw the triangle. This is what happens. The side A is too short. You can't get to the angle B. And so that's why there's no such triangle that will satisfy those conditions. But you don't have to try to construct the triangle every time. That's really going to be an impossibility for you, or a headache. You can just go through the law of sines, and if you get a value of sine that's outside of our value of 1, then you know that that triangle doesn't exist. So let's look at another case. And let me back up. The case where we had an angle, angle, side, or angle, side, angle will always give us one unique triangle. So it's just this case when we know two sides and an angle where we have this 3 different possibilities, ambiguity. So now we have to solve the triangle if A is equal to 98 degrees and A is equal to 10 and B is equal to 3. Well, one thing that's true here, if A is equal to 98, it is an obtuse angle. So that means that angles B and C have to be acute, or less than 90 degrees. So this is actually going to be one thing that will help us to see that we only have one solution. Now, with the values of the sides that are given, you still have to see that the angle could be constructed, but let's see if this will work. So we have to set it up in terms of ratios that we know, so let's think about this here. We need to find angle B, angle C, and then side C. So the first thing that we want to do, since we know everything pertaining to angle A and its side opposite, and we know a side opposite angle B, we're going to set up the ratio of sine A over A is equal to sine B over B. So we get sine of 98 degrees over 10 is equal to sine of B over 3. And then if we cross multiply, we get 3 times sine of 98 is equal to 10. Well, we don't have to do 10 times sine B, I'm sorry about that. We're looking for sine B by itself, so we don't have to multiply by the 10. 3 times sine of 98 degrees over 10 is equal to sine B. Using your calculator, we get 0.297 is equal to sine B. So now if you use your inverse function and do inverse sine, you're going to find that the angle has to be 17.3 degrees. And we know that it has to be acute, so that is an acute angle. Because technically, if you think about the unit circle, there is an angle in the first quadrant and an angle in the second quadrant that have the same sine value. So there really are two angles whose sine is 0.297. An acute angle and an obtuse, but we don't need the obtuse since we already have one of the angles in the triangle given as an obtuse angle. Now the other thing we have to do is find out what the measure of angle C is. Well, since we know the measure now of angle A and B, we can subtract from 180, and that will give us a measure of angle C. Right, 180 minus 98 minus 17.3 over 6 is equal to 64.7 degrees, so that's the measure of angle C. Now we can set up the ratio to involve side C, so A over sine A is equal to C over sine C. Plug in the values that we need or know, which are 10 over sine of 98 is equal to C over sine of 64.7. And then we multiply by sine of 64.7 to get 10 times sine of 64.7 over sine of 98 degrees is equal to C. And using our calculator, we get the 9.13. So this was a case where there's exactly one triangle that satisfies the information that is given. So let's look at the last case where we want to solve a triangle if the angle C is 31 degrees, the opposite side of angle C is 29 feet, and B is 46 feet. So in this particular triangle, we need to find side A and angles A and B. So what do we know? Things pertaining to angle C in lowercase c, and we know a lowercase b. So our first thing we're going to set up is sine C over C is equal to sine B over B. So we get sine of 31 degrees over 29 is equal to sine of B, we don't know, over 46. And then we can multiply by the 46 to get 46 times sine of 31 degrees over 29 is equal to sine B. And now using your calculator, you would find that value to be 0.817 is equal to sine B. Well, do you remember the last case we had an obtuse angle given? This is an acute angle given. So it could be that one of the triangles in this triangle, one of the angles in this triangle is obtuse. That's where we're going to come up with the two possibilities. Because whenever we calculate what sine B is 0.817, understand that there are two angles whose sine value is 0.817. There is an angle in the first quadrant. We call this angle B. Oops. then the reference angle, which is 180 minus b, also has that same sine value. So we have to think about that and see if it makes sense in this particular problem. Well, whenever we find out what b is by using the inverse sine, we get 54.8 degrees. Now the other possible angle that would exist is 180 minus 54.8, which is 125.2. So we actually have two possibilities, because if you add up the other angle, which is the 31 degrees that we know, there's still enough left over for this third angle in the triangle. So it makes sense that there could be two possible solutions. So we're going to take each of those separately. So our first case is dealing when b is 54.8. Then the missing angle, angle A, is 180 minus the 54.8 minus 31, which would be a 94.2. And now we plug into the law of sines. We know everything about angle C again, so C over sine C is equal to A over sine A. So we get 29 over sine of 31 is equal to A over sine of 94.2. And then we multiply by sine of 94.2 and figure out that A is 56.2. And what are our units here? I did not put those in this problem. They're feet. So lowercase a would be 56.2 feet. Now the other case that we have to consider is if B is 125.2. So then angle A would be 180 minus the 125.2 minus the 31 degrees that we were given. So angle A would be 23.8 degrees. And then we plug into the law of sines. So C over sine C is equal to A over sine A. So therefore 29 over sine of 31 degrees is equal to A over sine of 23.8 degrees. And lastly, we multiply by the sine of 23.8 degrees. Calculating that gives us that A is 22.7. So there's two triangles that we have that satisfy those conditions that we were given. So if you have any questions on this, please don't hesitate to contact me. Thanks.